to 10 largest space telescope in history, 100x powerful. The biggest telescopes in the world are often the most successful at making new space discoveries, due to their ability to collect more light and delve into the universe's history from impressive distances. Despite space observatories such as the Hubble Space Telescope, HST, and James Webb Space Telescope, JWST, being closer to the action, ground-based telescopes can achieve greater dimensions and are far less restricted by weight. When telescopes on Earth are built in a good location, with wide sky views, they can focus on a range of specific areas or events, unlike space telescopes, which need to be in the right place at the right time. Some of the largest telescopes are serving as Earth's eyes to explore supernovas, galaxies, and other distant objects. Here are the 10 biggest telescopes in action and in progress today. Hobby Eberly. Before its success as one of the world's largest optical telescopes, Hobby Eberly's design was unique. One element that helped make it stand out from existing telescopes was that its mirror is always tilted 55 degrees up from the horizon. This might sound restricting, but its rotating mechanism means it can still observe 70% of the visible sky. The telescope's mirror has 91 hexagonal segments to collect visible light. The most noteworthy discovery captured by Hobby Eberly was light that originated from a quasar so far away that the Earth was only an eighth of its current age when this light began traveling towards Earth. A quasar is an incredibly bright object that gains its energy from a supermassive black hole. Keck telescopes, despite being Earth-based, the twin telescopes at the Keck Observatory, can see farther into space than the famous Hubble telescope. This means that around a quarter of the observations made by US astronomers are achieved using Keck, and it is considered the most scientifically productive of all land telescopes. By incorporating optical and infrared telescopes, the observatory produces clear images in the visible light spectrum, but also allows astronomers to see deeper into space using infrared. Some of the incredible imagery uncovered by this combination of apparatus include the birth of stars, which can produce a visible glow and also heat up surrounding gas that can be detected using infrared. The observatory is positioned near the equator, and at the top of the dormant Hawaiian volcano, Mauna Kea. There are 36 mirrors that make up each telescope, joined together to make one large panel. Concealed in insulated domes, the two telescopes operate at temperatures slightly below freezing to prevent heat from interfering with the infrared images. South African Large Telescope, SALT. The design of SALT appears almost identical to Hobby Eberly because it was inspired by the success of its predecessor. SALT has the same number of hexagonal panels as Hobby Eberly, but was redesigned to improve its field of view and image quality. Mirrors of SALT also have a higher sensitivity to short wavelengths, due to additional layers of metal being added to them. Among SALT's top discoveries is the first white dwarf pulsar. This is a fast-spinning star remnant of a white dwarf. Atacama Large Millimeter Array, ALMA. ALMA consists of 66 radio telescopes, with 54 measuring 39.4 feet, 12 meters in diameter, and the remaining 12 just 23 feet, 7 meters. Collectively known as an astronomical interferometer, each of these antennas works together to create one image. When this array is used in different combinations, the range of visibility varies. This is essential for targeting the desired galactic areas. One of the groundbreaking discoveries made by ALMA was the most distant oxygen in space. This is a record that the telescopes have broken more than once. The furthest detection of oxygen in space was 13.28 billion light-years away, and evidence of this was picked up by ALMA in 2018. Due to the expansion of the universe, the infrared light that had been emitted from this oxygen was converted into microwaves as it stretched. The signal came from ionized oxygen in the galaxy Maxwell 49 JD1 30-meter telescope, TMT. This project is currently in progress as part of a collaboration between Japan, the National Institutes of Natural Sciences and National Astronomical Observatory, the US, Caltech and the University of California, Canada, National Research Council Canada, China, National Astronomical Observatories of the Chinese Academy of Sciences. Square Kilometer Array, SKA. Although the individual size of each of these telescopes isn't as grand as some of the previous entries, the anticipated scale of this construction is much greater. Chosen for their extremely remote lands, the Karoo region of South Africa and Murchison Shire of Western Australia are due to host the massive radio telescope arrays. In Australia, which is planned to be home to the largest of these sites initially, there will be 512 telescope stations, while 200 will be situated in South Africa. Scientists estimate that the result of this project will be telescope arrays that are 100 times more sensitive than today's top sites, and a sky surveying time that is around 1 million times faster. The targeted completion date is in 2028, and the arrays are expected to be used for around 5 decades. Extremely Large Telescope, ELT. Designed by the European Southern Observatory, ESO, the extremely large telescope, which is due to be completed in 2027, also holds extremely lofty goals. These include discovering Earth-like planets and searching for life beyond the solar system. Due to its significant mirror surface area of 10,527 square feet, 978 square meters, the ELT will be able to collect 100,000 times more light than the human eye. The telescope will be encased in a huge 262-foot, 80-meter tall rotating dome, which will weigh approximately 6,000 tons. The strong foundations for this telescope were completed at the beginning of 2022. 500-meter aperture spherical telescope. FAST. The 500-meter aperture spherical telescope, FAST, located in a natural karst depression in Guizhou Province, China, is the world's largest single-dish radio telescope. Operational since 2016, FAST has a diameter of 500 meters, allowing it to collect radio signals from the furthest reaches of the universe with unprecedented sensitivity. Its primary mission includes the study of pulsars, the detection of neutral hydrogen in distant galaxies, and the search for extraterrestrial intelligence. FAST's vast collecting area and advanced receiver technology enable it to survey the sky faster and more comprehensively than any previous radio telescope. This monumental achievement in engineering not only enhances our understanding of the universe's fundamental properties, but also positions China as a leader in the field of radio astronomy. FAST's discoveries are expected to reshape our knowledge of the cosmos and contribute significantly to the global scientific community. Giant Magellan Telescope, GMT. The Giant Magellan Telescope, GMT, is poised to revolutionize our view of the cosmos with its unparalleled size and capabilities. Currently under construction at the Las Campanas Observatory in Chile, the GMT will boast a total aperture of 24.5 meters, composed of 7 8.4-meter segments. This extraordinary telescope is designed to achieve 10 times the resolution of the Hubble Space Telescope, making it possible to observe the faintest and most distant objects in the universe with remarkable precision. The GMT will address key questions in astrophysics, such as the formation of stars and galaxies, the nature of dark matter and dark energy, and the search for potentially habitable exoplanets. Set to see first light in the late 2020s, the GMT represents a significant international collaboration, with contributions from institutions across the globe, underscoring the collective effort to push the boundaries of human knowledge and exploration. Gran Telescopio Canarias, GTC. The Gran Telescopio Canarias, GTC, is one of the largest and most advanced optical telescopes in the world. Located at the Roque de los Muchachos Observatory on the island of La Palma in the Canary Islands, Spain, the GTC features a primary mirror with a diameter of 10.4 meters. This cutting-edge facility allows astronomers to explore the universe with unprecedented clarity and detail, providing valuable insights into the formation and evolution of galaxies, stars, and planetary systems. Since its inauguration in 2009, advancing our understanding of the universe's fundamental processes.